I wanted to thank everybody for coming again. And just as some friendly reminders, whenever you do speak, please try to grab one of the mics. There should be one on each table. And we should have one or two people on the phone. And whenever they speak, I'm going to try to put the mic over them so y'all can hear. We do have some beverages and refreshments in the back if you're inclined. And I think we're ready to get started.
How's the audio? Everybody hear her okay? No, it's not good. You can hear Mary. I have a question though. I tried to listen to the audio recording. And I couldn't hear it. Maybe it's just my computer. Has anyone else tried to listen to it online? I couldn't hear it.
Yeah, so we have some of the stakeholders mentioning they couldn't hear the recording. And I did have, with one of our previous recordings, it played fine on my computer, but then downstairs, they had to, they only heard it out of one of their earbuds, just like the right side or the, so I don't know, that may, but I will definitely look into that. I'll look into the recording and see if we can't get that fixed.
Can everybody hear me? Okay, good. Everybody hear me? Okay. Anyone? Okay, good. My name is Sarah Clem. I'm the planning branch manager for the Water Quality Planning Branch at ADQ in the Office of Water. Caleb Osborne is our associate director. He was here last time. He's not able to be here this time. He's expanding his family. So right now, so he's not here. So he's in a good place right now. So thanks again for coming. We have a good turnout again, and this is exactly what we wanted. So thank you all for coming. It's a long haul for a whole day to be here from 1 to 4. We anticipate having our 1 to 4 time slot continue. We believe right? We're going to have our 1 to 4 time slot continue for the other events that we have planned for the stakeholder work group meetings. And there might be a possible change on the 12th, but we're going to let you know. That's when our next one is set up for, I believe. There might be a change in that, but we'll let you know as soon as possible. So, good to go? Everything else? So, anybody else on the phone? Good. So if you would, folks on the phone, if you wouldn't mind having the phone on mute while we're listening. The next thing on the agenda is a presentation from USGS. So the presentation is an evaluation of a continuous monitoring data for assessing dissolved oxygen in the Boston Mountains by Billy Justice and Luke Driver with USGS here at this office in Little Rock. So this is, I'll just let you go on this. There's a presentation. We're going to dim the lights, if that's okay. And if you can't hear Billy, just let him know.
Okay. Yeah. So I'm Billy, and glad to be here. I was not able to make the last meeting. Might recognize Luke. Luke was able to make the last meeting. This is a joint presentation, and Luke's going to start us off. This project was funded by ADQ. It's been ongoing now for 7 months or so, probably, and involves, as you'll see, quite a bit of data compilation over the last few years. Luke.
Good afternoon. So we're going to present some data that the title kind of speaks for itself. but we've been cooperating with ADEQ to try to get a handle on how to use continuous monitoring data specifically for DO so they can assess and evaluate the current DO standards. So just a little bit about the USGS. For some of you guys who may not be familiar, USGS has been around for a long time. I think our organization's been around since 1879 or so. Right now, the USGS is divided into different mission areas: water, ecosystems, energy and minerals, natural hazards, and climate and land use. Our office here in Little Rock is part of the water science mission area, and we're part of the larger 5-state region of the Lower Mississippi Gulf Water Science Center. So just in general, USGS Water Science Mission Statement, we try to provide reliable, impartial, timely information in order to understand the nation's water resources and really to get at protection and enhancement of water resources for human and aquatic health and environmental quality. I'll just preface this by saying that USGS is strictly a non-regulatory agency, so our role here is to provide the science and the data, and then we hand it off and let other folks run with that. So, for the national and state standards, many of you are probably familiar, but the Clean Water Act and EPA's regulation and standards over the last several decades, some of them are largely unchanged. So. National standards are passed down to the state, and it's up to the state to implement and develop. Some of these national standards are relatively unchanged and are very generally applicable and don't really address specific on-the-ground characteristics of different ecoregions or water bodies. That being said, for the current DO standard in Arkansas, based on the different level 3 ecoregions. I think there's 5 or so level 3 ecoregions. This is a table that, there we go. I'm going to have to use the mouse a little bit because we're going to have to point and stuff. So can you guys see that? Okay. So this table just highlights some of the 3 of the 5 level 3 ecoregions. So there are different DO standards currently in place for different ecoregions. And there are also different standards in place that separate different seasons. Okay, based on either temperature or month. Based on the seasons, there's a primary season and a critical season. Critical season is really what we're interested in. The critical season is water temperatures that are above 22 degrees C. That's recognized as potentially conditions that are potentially harmful to aquatic health. Okay, that's when we have low DO, high temperatures, and physiological stress. So. In the past, data collection generally been discrete samples. I'll describe what that means here in just a second. Or sometimes continuous samples, but often on a short-term time scale, so 72 hours or 96-hour period. And the current language that's used by an ADEQ right now for listing streams as impaired is a stream or a river monitoring segment will be listed as non-support where more than 10% of the total samples for the primary or critical season fail to meet minimum applicable DO standards. So what we're going to present is using continuous data to try to get at evaluating the current standard. Discrete sample data is usually a specific point in time. Discrete data can be collected periodically, either monthly or seasonally type thing, but generally requires someone to be actually out in the water body collecting data. Bring the data back to the lab or send it off and process or analyze. With new technology, continuous data networks are really being developed. So these are generally kind of remote sensing stations that you put probes in the water or you put machinery in the water that collects data at a certain interval, and then, depending on the technology, depending on what's set up, can wirelessly transmit that data via satellite to our data repository. So at USGS, we have pretty strict protocols. We've got a lot of methodology in place that evaluates continuous data as far as data quality, so QA and QC. Here's just an example of some of our continuous monitors. These are for water quality. I actually have one here. If people are interested in looking at it, we brought one as an example. But this is a machine that you put in the water. Let's see if I can get the mouse up. There's different brands. Predominantly, we use a YSI model. It's called a SOND. YSI is Yellow Springs Instruments, but there are other models out there. Hydrolab has similar instrumentation. But this is a machine that has several different probes attached to it. You can see in this picture, there's several different little probe modules. This is kind of customizable, but there are standard ones. So DO, temperature, specific conductance, turbidity, salinity. There are several others that you can kind of customize depending on your needs. We have calibration and maintenance protocols. So these machines are calibrated in the lab. There's cross-calibration or side-by-side calibration with meters in the field to make sure that we're reading accurately. We have a maintenance protocol. So for our... Ooh, nice. Okay, maybe that'll work. So for the monitors that we have out in the field right now, they are maintained and replaced or calibrated on a rolling basis. So it's every 3 to 4 weeks, I believe, for our technicians. So essentially our objectives here is working with ADEQ to compare dissolved oxygen variability, looking at sites that represent least disturbed, as well as a gradient of disturbance, so some sites that are more or less disturbed. And we chose the Boston Mountains ecoregion, and we're looking specifically at the critical season, so water temperatures above 22 degrees Celsius. We're also looking to evaluate the current standard and identify if continuous dissolved oxygen data collected on a 15-minute interval is appropriate for the current assessment methodology. And secondarily, this kind of evolved as we were looking at some of the data, is to use other continuous variables that are associated with DO as potential surrogates that may help to explain patterns in DO. So other variables such as pH-specific conductance and water temperature. So the continuous monitoring network that we have right now is expanding. Right now we have 21 or so continuous monitors that monitor DO across the state. We chose the Boston Mountains ecoregion because of those 21 throughout the state, most of them fell within the Boston Mountains, so we had kind of a larger data set to choose from. So we chose 5 sites within the Boston Mountains. We're using the USGS gauge number here, and that doesn't help you guys, but I'll kind of point these out. And it looks like the points may fall outside the line, but their watersheds actually drain in the Boston Mountains. So this top dot here, I believe, is Town Branch near Fayetteville. The one right next to it is White River near Fayetteville. This is Big Creek at Carver, which flows in the Buffalo River. This is South Fork of Little Red River right here. And this is Illinois Bayou. And you'll see these as I go along. So some of the basic characteristics, this is just a descriptive table here with the sites. Drainage area, the period of record we have for some of this continuous data is actually larger than what we selected here. But we chose a period that we knew we had some approved checked data as far as our data monitoring QA/QC, so this is approved data. The number of critical temperature days, that's just the number of days that water temperature at some time was at or above 22 degrees C. And the number of unit values. The number of unit values here is actually important. So when you're thinking about continuous data, a unit value is one single 15-minute interval, or one 15-minute value. So this date range for 4 of the 5 sites covers 2 summers. The last site here, Town Branch, is a newer addition to our network, so our period of record is a little bit smaller. So that only covers 1 year of data. But if you look at the number of unit values, our highest number of unit value, we're upwards of, close to 30,000 data points. So just in comparison with some discrete data and maybe some periodically collected data, this is a pretty rich data set, even if it's only 2 years period of record. So we selected sites that were had a watershed area greater than 10 square miles. That's partly because of the current state standard that has a little bit different standards depending on watershed size. And we really wanted to choose sites that represented a gradient of least impaired to kind of most impaired. Okay, we're going to try and stay away from the word reference because this may not necessarily be reference streams, but least impaired. Oh, my arrows are there, but okay. One important thing to realize is that as far as impairment is concerned, so looking at dissolved oxygen, there's a relationship between DO, nutrients, and land use. Okay, so intensified land use, really think like anthropogenic or it's not necessarily urbanization in this region, but intensified land use. So agriculture, other sorts of human land use. Increases nutrient concentrations in streams, generally. When you have an increased nutrient concentration, that can often stimulate primary productivity, so periphyton, algae, phytoplankton, and macrophytes. Increasing plant productivity obviously increases photosynthesis and also respiration, and the interplay of photosynthesis and respiration changes the variability in dissolved oxygen on a daily basis. So diel just means day and night. So going back to some basic, maybe high school or undergrad biochem or biology, understand the process of photosynthesis and respiration. So in photosynthesis, in sunlight, the main thing to take away here is carbon dioxide is consumed and oxygen is produced. Respiration, on the other hand, oxygen is consumed or taken out of the system, and CO2 is pumped into the system. So you have this fluctuation of dissolved oxygen concentrations and dissolved CO2, and so dissolved oxygen goes up and down depending on photosynthesis versus respiration. Really what we're concerned with here is what's happening during sunlight hour or photosynthesis. So if plant productivity is high, again, the variability in dissolved oxygen can increase. So going into this, again, we were looking at these 5 sites that represented a gradient. We needed to try to evaluate the current DO standard. So in order to kind of evaluate some of the actual unit value data, we designed these a priori designations based on nutrient concentrations and land use at those different sites. So using nutrients and land use, we classified sites loosely based on least impaired, moderately impaired, and most impaired. I'll just clarify that a little bit. The idea is that if we look at the dissolved oxygen data, high DO generally represents a higher quality stream as far as providing oxygen and a conducive environment for biological and ecology, whereas low dissolved oxygen can be stressful. Okay, so we would generally think that higher dissolved oxygen would be least impaired stream, lower dissolved oxygen would be more impaired. We did not measure continuous nutrients. I'll show some in this slide, the nutrient data. So we use some nutrient data for this ranking system, for this a priori designation. This nutrient data is based on some periodic and discrete sampling. That's part of the USGS sampling protocol. And you can look at the number of samples up here. This nutrient data is somewhat limited for specific sites. We don't have a whole lot of nutrient data at some sites. But we took mean nutrient data from these 5 sites. We separated, so nutrient was nitrate and total phosphorus. We separated our nutrient samples from base flow versus storm flow samples. When you get a storm flow sample, you have lots of surface runoff, and your nutrient concentrations can actually increase and specifically for phosphorus, you can have magnitudes of increase. So we separated those out so we wouldn't necessarily bias our base flow sample, which is really what we're, it's the norm, not normal conditions, but the predominant conditions. We rank sites based on mean nutrient concentrations for each of these. So a ranking here, here, and here. So low nutrients we considered to be least impaired, and higher nutrients were more impaired. So the far right side of this table, we summed the ranks for each of these 4 metrics. You see this final ranking. That's our nutrient ranking. So the list of sites there is listed in as far as nutrients, what we consider to be least impaired to most impaired. And you can see that South Fork of Little Red came out as number 1 as far as least impaired. Town Branch was most impaired in terms of nutrients. Similarly, we did this for land use classifications, and Jesse was involved in some of this, but we ranked sites based on different land use percentages. There were a lot of different metrics that went in, these different land use metrics, so we're not going to get into all that, but basically the sites ranked similarly for land use that they did for nutrients. There's a little bit of flip-flop in number 1 and number 2 rankings here, but essentially South Fork, Little Red River, and Illinois Bayou were least impaired, and Town Branch and White River were most impaired. Other constituents that we looked at specifically was specific conductance, water temperature. So these can play some important roles in interpreting some of this DO data, because we know that conductance and water temperature can be surrogates for groundwater influence. During low flow periods, large parts of stream flow can come from groundwater. Specific conductance oftentimes in groundwater is much higher than surface water. And when you have lots of groundwater influence, DO is often very low in groundwater. So that can play with some of your results. So we wanted to pay attention to that. Additionally, pH was an important additional surrogate or consideration because values of pH are related to productivity and photosynthesis. So when you have photosynthesis, it produces or takes CO2 out of the water, which can increase pH, and during respiration, it puts CO2 back. What do we say? CO2 is added back into the system, which is a weak acid, so it can actually lower the pH. This will be important when we start talking about the results. And with that, I'll hand it over to Billy.
How's the pointer work? Okay. So, most of you are probably familiar with box plots, but because the summary tables, even the summary tables for dissolved oxygen, pH, all the variables that we're going to be talking about are pretty big. The font's pretty small. We're using box plots to describe our data for the next several figures. And if you take the columns that are in this table, ranging from minimum values over here on the left to maximum values, we have those transposed down onto the box plot. So if you look at Quan 10, for example, that's the point at which 10% of the data are below that point. The first Quan is the 25th percentile. The third Quan is the 75th percentile. So that's how these data will be described. Probably most important out of all of those is the median, which will be the line in the center of the box. Where are my arrows? Where is it? Okay. So the first and most important graph probably is the summary of the dissolved oxygen data. Again, the 5 sites will be listed across the x-axis at the bottom in the same order that they've been listed in the tables. So the first 2 sites, which have the narrative designation of being least disturbed, did have slightly higher mean concentrations for dissolved oxygen. As you can see, the central bars, all of this data pretty much reflects what we saw with the a priori designation with the nutrient and the land use indices. You see a slight decrease in mean nutrient concentration as you go across those 5 sites. The 2 sites with the most disturbed designation were quite different, as you can see, from sites that were the least disturbed. These sites, the circle at the bottom indicates the percent of unit values that exceeded the 6 milligram per liter standard. In both cases of the least disturbed site, it was less than 4%. And in the cases of the 3 sites that were more disturbed, they were ranged between 20 and 33%. The specific conductance and water temperature generally indicated there was some degree of groundwater influence, particularly at 2 of the 3 sites that were most disturbed. Those 2 sites were Big Creek and Town Branch. If you look at the if you look at the Big Creek specific conductance, conductance ranged about 300 microsiemens at that site. It's pretty high. That's indication that you got some groundwater influence there. And if you cross over to the other water temperature, you'll see that it also had cooler water temperatures. So those 2 things are indicating that we have some groundwater influence there. You would expect, if you got groundwater influence, to have some variability in dissolved oxygen that would be explained by that groundwater influence. You look at the specific conductance of the 2 sites. Now, there can be natural differences in specific conductance, at these sites. Urbanization, particularly sites, the 2 sites that have more urban influence would be expected to have higher specific conductance that's unrelated to groundwater. pH was much lower at the least disturbed sites compared to sites that were most disturbed. That's the probably indication that we do have more photosynthesis going on there. The higher pH, you have more oxygen production that's associated with productivity. One of the things that really stood out with us is that this relationship between dissolved oxygen, this is a table, the table there indicates that you got 5 negative values, correlations between specific conductance and dissolved oxygen, and 5 positive correlations between pH and dissolved oxygen. So it kind of substantiates our conceptual information that we've been telling you, that as you got that groundwater influence, then there was a negative effect on dissolved oxygen. As you get that, increase that pH influence, there's a positive effect on dissolved oxygen. And just as an example, we pulled the scatter plots for just the Big Creek site. And these scatter plots down at the bottom, this is not a perfect example, but it is the data. You have a correlation that corresponds to what's in the table, but a correlation that about 0.48. That's a wedge-shaped scatter plot. Much stronger scatter plot. That was for specific conductivity compared to dissolved oxygen, so it goes down. As you get higher pH, again, you have a strong relation to dissolved oxygen, and that's demonstrated on the right-hand plot. That's a very strong relation between dissolved oxygen and pH at this particular site. And one of the things that was, really stood up again, that of the sites that had the strongest association to pH, they were at the sites that were the most disturbed, and which is, that high correlation is again another strong indication of high productivity. So to kind of summarize what those 4 or 5 slides I just showed you, even though some of the low end variability can be explained by groundwater influence, sites with the highest amount of DO variability generally did have the highest nutrient concentrations and most intensive anthropogenic use. And another way of looking at it is more DO data. This is the amount of daily variability in DO concentration at the sites. And again, you see much higher variability at the 3 disturbed sites. Big Creek had the most variability. Conditions are right there for a high productive situation. May not be just nutrients, could also be that you got light limitation at some of the other sites, but you do have have some productivity going on there. So this is a draft report. We hope that in the next month or so to get it into official USGS review. These our preliminary conclusions are that DO concentrations at the least disturbed sites exceeded the Arkansas standard of 6 milligrams, less than 4% of the unit values. That indicates that the current standard is obtainable, or that it's probably not too high, at least, and that continuous DO data that was really why we did this project can be used appropriately with the current assessment methodology to determine when we have that 10% exceedance of the 6 milligram standard. Secondly, some of the DO variability at the low end of the data range, near the 6 milligram per liter for some sites in the Boston Mountains, may be explained by groundwater influence. However, a high degree of variability at the upper end of the range indicates a connection to nutrients. So future directions, we're working with ADQ. Hopefully they'll be able to use our data. The most significant part of this project to me, not being a programmer, was the amount of effort it took to pull the data, thanks to Luke and a few other folks at USGS for doing that. But we're getting that code written, those scripts produced so that we can give that to ADQ, and hopefully they'll be able to use the data with those codes. So I'd like to acknowledge Brian Breaker at USGS for working with Luke and really doing a lot of the data manipulation or pulling the data. Also, Tate and Jesse have reviewed a couple of drafts of this report and continue to provide help. Yes, sir.
Okay. Your data sets that you used on this included both base flow and storm flow.
Yes, sir.
Okay. Did you run it just on base flow?
Now, the nutrient data was just from base flow and storm flow.
Well, and the point of my question is, during storm flow events, you'll have a lot of mechanical aeration of water.
Right.
So that the influence of nutrients or some of these other constituents in water would be much more masked by the mechanical aeration.
Right.
So I'm wondering if you just ran it on base flow.
We did try to eliminate the high flow event, the times when we had high flows when we pulled the old data. Right, Luke?
Yeah, but most of that is based on really the designation was for the critical season or temperature.
Right.
Yeah.
So during the critical season, we tried to focus on dissolved oxygen concentrations that were at the base flow periods. Not just base flow, but not storm flow periods.
Well, wow, sorry. I don't believe that we filtered that data for the storm, the raw DO unit values. Storm flow values are in that data set. That data set was filtered for values above 22 degrees C. So just to be clear, that the DO variability does include storm flow samples. The nutrient data, and there was some filtering for base flow and storm flow, but raw DO was included both.
Which would make sense, because I don't think in Reg 2, I guess that would make sense, because as far as exceedances at the 10%, as far as Reg 2 is concerned, doesn't matter if it's during a base flow or storm flow event. You group them all together. Reg 2 doesn't segregate when the exceedances if it's base flow or storm flow.
22 degrees Celsius is the primary
That's the,
division
okay,
point. That's your first categorization.
okay.
So I want to call your attention to, on page 38, number C. It says the critical season dissolved oxygen standard is to be met at maximum allowable water temperatures and at Q7 to 10 flows. However, this is the important point, however, when water temperature exceeds 22 degrees Celsius, a 1 microgram per liter diurnal depression will be allowed below the applicable critical standard for no more than 8 hours in a 24-hour period. So I think that's pretty important, that there's sort of an exemption there that allows it to be exceeded even more, unless I'm reading that incorrectly.
So it took me a while to
Sorry.
filter through all my notebooks that I have.
Page 38,
38.
number C.
You're looking at C. Okay, so Teresa, so I would say, that is true. It is in Reg 2 in 505, if I recall correctly. So if that's right.
Oh, I
505.
apologize, because this is for effluent discharge limits.
Yes,
So
that's-
I apologize. I was thinking it was all grouped into one.
Yep, that was the next thing I was going to say.
But so
Green.
I did have a question on page 38, why that is in the assessment methodology, since it is directly related to NPDES permit limits.
We have to get more microphones. But I would say that that's what we tried to do. What we've tried to do in the assessment methodology is to give one what is exactly in the reg. But that's a good point. We do need to take that out because it is for effluent discharges. So, I mean, we can capture that. We would capture that point that you just made and take that out. But Luke, did you want to say something?
Yeah. So we did do some analyses looking at the hourly mean DO values and evaluated the 10% exceedance using hourly means, and we actually had a table that set up the mean number of hours that exceedances per site. But we ended up not using that because we really wanted to use the unit value continuous data. In order to get the hourly means, we have to kind of condense that data set into, it's a little bit less resolution. Instead of 15-minute intervals where you have 96 values per day, is that right? You would have 24 values per day. So we went with the unit values just to have a higher resolution. We did evaluate on an hourly basis, and we do have some of that information available.
Yes.
Okay, did you guys look at how the standard was initially created? What data were used to create the standard initially?
My recollection is that I might have to defer to Tate, but that we did look at how the data was gathered, which I believe was 72-hour diurnal studies for the original ecoregion work. So, but what so the ultimate take home, not for us, is can we utilize that 10%? Can we utilize that 10%? And what you're telling us, and this is the reason we wanted you to conduct the work, is that 10% is appropriate. So looking at some of those data sets that were, so for example, in one of them essentially a year, I think, a Big Creek, and it's about, what is it? It would be 14 months, I think, is the period of record that you used. And it was 20-something, 27,000, 24,000, 22,000 data points. So we would essentially, we break it down, that's 10%. We would take the 10% of those data points. Does that exceed? Yes, no. Anyone add anything to that, Bill?
Just that, out of those 21,000 or however many out of the 21,000 or 22,000 record points, I think, was it 27? One of them was 27, one of them was 21,000. But out of those, at Big Creek, there was exceedance of just slightly over 20%. Yeah. That didn't change a lot when we looked at the hourly values, and it was just more straightforward to use the unit values. But we did. Okay.
So what we're saying is we would be using how are we going, that was a question for us in 2016. How do we want to evaluate this continuous data? Certain states do it differently, and so what we want to do is evaluate how are we going to do this? How are we going to do this for 2018? That's why we hired USGS to look into this issue, and so this is what this is where we are. So 10% seems is appropriate. We believe is appropriate. So what Mike's thinking. Teresa wants to talk. Anybody? Okay. Stan wants to talk. Okay, Stan, you guys have already talked, so I'm going to let Stan go. Okay.
Okay, my name's Stan Sewell, and I guess the question I had early in the presentation, y'all talked about 30,000 approved, quote, checked data points. And I guess the question I would have, did y'all remove any data that you collected? And if so, what were the reasons for removing the data? And I guess what I'm looking at there is typically there's a data validation process. And so if that was kind of what you were doing, were you able to pinpoint why you needed to remove the data? And I guess as a quick follow-up question to that is, you talked about the field units being there for some 3 to 4 weeks. Was it a part of your protocol to check for things like drift and that sort of stuff?
Right. That's in our technicians who maintain the monitors. They also are responsible for looking at their data, looking at those data, and they go through a review process. I mean, if you look at all of our data on our web, it says preliminary data subject to review. Well, at a certain point in the year, they look at those data and do a review. So if a monitor goes down, or there's fouling, or a crawdad gets in the cage with the monitor or whatever, some of those data would be removed. But that would occur at that level. It wasn't something that we did individually by ourselves.
Yeah, I just know doing a lot of that, despite best efforts sometimes.
Yeah, it takes a lot of time. I mean, when the actual quality assurance for these data, it's something that, whoever's responsible for that monitor needs to be looking at that data every day or two to be sure that it's transmitting, pretty much what we would expect.
Thank you.
And just like you said, the check and review process, there's corrections and, you can look at the data if there's drift. There are protocols in place that we can correct drift in the data. And that's not something that we do specifically, but that's on the data side. The data technicians apply corrections to data that's drifting.
Thank you.
This is Colleen Gaston. So if you're going to stick with the 10% rule and use the continuous monitoring data and use all the unit values to determine that, what will you do if you don't have a 5-year period of record with continuous monitoring data? In other words, how will you combine the continuous monitoring data with discrete DO samples?
We have, have we discussed that yet? Tate, do you have a? I mean, I'll be honest. I mean, some of these, we still have some of these questions that we haven't answered about how to, because we start thinking of these minutia that come up. How do you, these incidents that maybe don't happen 90% of the time, but like, what about that 10% or 5% of the time? How do you evaluate when you have this data combination? So we're still, some of these questions that you may come up with, which are great, we may not have an answer to them yet. But so I'm just going to be honest. But go ahead, Tate.
We have talked about that internally.
Has to be green.
So we have talked about that internally, but where we're at right now is that from our conversations with USGS, if we have a limited data set of continuous monitored, so 12 months of continuous monitoring, and we have paired discrete data, 12 data points throughout the year, monthly samples, we would tentatively lean more on the continuously monitored data because that's more indicative of what those organisms are seeing for the protection of that designated use. That's very tentative conversation, but that's where we would lean. If we only have one of either discrete or continuously monitored data, that's still up in the air. Where, if we only have one or the other, how would we really lean on that? I mean, I think we would continue our normal practice of where we're at with that, because that's how we evaluate discrete sampling already.
Teresa Turk, Buffalo River Watershed Alliance. What I would really like to see is really a little bit more analysis. I mean, I think this was great what you did. I think this is really insightful. But, some states take the lowest dissolved oxygen point from continuous data in a single day, and they use that point to characterize the entire day. So I think it would be very interesting to see a comparison between the lowest dissolved oxygen point in a single day versus the way you collapse that data into every hour, and then with the data points that you have on a 15-minute interval, and just kind of have a little analysis, because I think really it's how protective we want to be in this state of our streams. It's not whether it meets this, who came up with the 10%, is that appropriate? We've learned a lot more information over the years. We may want to consider being more protective, but it sure would be nice to see how those three types of data line up with each other.
So, Billy and Luke, correct me, I'm pretty sure we did evaluate the daily DO minima in this exercise, and there wasn't I think that's going to be part of this draft report. We'll be comparing the three methods of looking at what other states have done, the daily DO minima, the hourly average, and the 15-minute discrete interval samples, and there really wasn't a difference in this exercise.
Well, that's great. I would love to see that. When do you have an idea when the report's going to be done, when you'll make it available?
Well, that probably, I expect it would be approved somewhere in a 3-month time period. It's getting it in submitted pretty quick. Yeah, that's generally what it takes.
I have a quick question, Colleen, again. So I just happen to know that the White River and Town Branch monitoring is partially paid for by Beaver Water District, I believe. So that's what, is that correct? Do you know? I think that's correct. And the city of Fayetteville and maybe some others. I don't know if Beaver Watershed Alliance is paying for some of that. But anyway, there are funds going towards that continuous monitoring data that probably aren't available elsewhere. So my question is to ADQ, when and where does this, or does the state pay for any continuous monitoring data? And how's that decided on when and where that's done?
So we do contribute to it's we do contribute to USGS and provide funds for monitoring stations. They're how they divvy up, how they distribute. I mean, this gets into how they distribute their the funds that they receive for certain to run certain gauges. It's not always. We can specify which ones we want to contribute to, but it's up to them. We don't say we want a certain amount to go here and a certain amount to go there. You guys, I don't really want to get into how they distribute their funds and how they pay for their gauges, but we do contribute to gauges, continuous gauges across the state. So.
Well, yeah. I mean, we have most of the ADQ string gauge program has been cut in the last few years, right? And I think that's what
This is a gray area. So we had contributed more, but as our resources diminish, then we are not able to distribute them as we want to. But I mean, we have our budget for USGS engaging stations has decreased throughout the years.
Okay. So, but in general, if anyone, any state agency or anyone wants a continuous monitor, then we do work with them. Mm-hmm. Yeah. So we have gauges. These gauges, these continuous monitors are pretty expensive to run. I mean, if you're looking at 4 or 5 parameters, you're looking at $25,000 a year, probably on average. It goes down a little bit as we use the data more, but.
What are you getting at, Colleen?
Well, what I'm getting at in terms of assessment methodology, that the use of continuous monitoring data is going to be the exception rather than the rule. Yeah. That for most water bodies, you're going to be dealing with discrete sampling. Is that?
Yes. Right. Okay.
Additional questions.
You'll always see a diurnal fluctuation in DO. I mean, the amount of diurnal fluctuation is really what causes us concern. But, you know, you got sunlight during the day, you got oxygen production, you have only respiration occurring at night, so you have DO depletion. So you're always going to have, we expect, you know, in a natural situation to see 1 or 2 milligrams per day, you know, depending on the water temperature and how much light you have, you expect to see that. It'll increase more with additional. Well, you'll have your lowest dissolved oxygen concentrations about 6 o'clock in the morning or daylight, and then it'll gradually increase up to the maximum value about 3 or 4 o'clock in the afternoon.
Anybody have any more questions?
Sarah, just one more, and
yeah,
I don't
sorry,
want to
Mike.
belabor the point because we'll probably talk about it again when we get into the continuous monitoring for dissolved oxygen. But it would seem to me, just from listening to Billy and Luke, and considering the use we're protecting here with dissolved oxygen is really aquatic life.
Yes.
And so the importance of focusing in on the most critical periods that aquatic life have to go through would be your temperature and then your base flow, because your wetted perimeter is the smallest and they're the most stress for aquatic life would be during those time periods. So it would seem that your impairment assessment would focus on those most critical periods and get away from or partition off those time periods. And I'll go back again to my comment about storm flows. Storm flows, you have a lot of other inputs to oxygen, one being mechanical aeration. So I would not expect dissolved oxygen to be an issue during storm flow events above a certain, flow. But at base flows, especially those 7Q10s or that bottom 25% quartile would be the time period that those aquatic organisms have to go through and live through the most stressful period event. And so that's where the focus should be on what are the dissolved oxygen exceedances then. Because you only need one for you to have an impact on aquatic life, even though you're saying, well, we need 10% of everything we're monitoring. But one event could be critical to the aquatic life inhabiting that stretch or that segment of river.
Mm-hmm. I still see I still see the 22 degrees Celsius as the primary controlling I guess the primary first step in looking at dissolved oxygen, and secondarily perhaps base flow, but still that 22%. I mean, 22 degrees C is you really still have to, and I didn't hear you say that, so that you may be thinking that's
The 22
definitely
degrees is
pretty high.
The 22 degrees is important and is correct. But the other parameter you need to look at is that base flow event.
Yeah, but when are you going
Are those base flow periods?
right.
Now, one thing I don't know and comes into this, because my concern here, Billy, is how much of this data is being influenced by that mechanical aeration during storm flow events. Well, that depends on how many storm flow events. What proportion of the data, those 27,000 data points, were during above 50% flow, or whatever it is, where you start getting more mechanical aeration than photosynthetic aeration. And that's really what I'm looking for, is how much masking of the impacts due to nutrients or land use or all those other things, because that was your premise, was higher concentrations of nutrients from land use or where it comes from is affecting DO. Well, if you're masking that during storm flow events, it seemed to me you'd want to partition that out. You want to take that data out and just look at those periods of time where DO is most affected by other water quality constituents.
Like you say, that would vary from year to year. But, you wouldn't expect it to be that frequently, but I agree, you're right. But, what we were trying to do was to evaluate how the dissolved oxygen standard that's currently in place works. And
Yeah,
and that
understand.
yeah.
I understand
and so
that.
that's pretty much our primary objective. So,
But you have the data set now where you could do that. You could partition out base flow from storm flow events and run the same analysis. And if there's no difference, if you're still at, I don't remember how many exceedances you had on the least disturbed versus the most disturbed, if it's still, the same, then okay. We're not having it, that's not influencing our attainment decisions.
The 22 degrees C is, there's a lot of overlap between 22 degrees C and base flow. So you wouldn't expect to have a whole lot of storm flow samples when you have, I'm not going to predict storm flow samples, but
But you still don't know that until you actually run the analysis. And that's what I'm saying. You've got the data set. It'd be easy to do.
And also touch on, is it Steve? Stan? And also one of your comments. So using the 15-minute unit value data, what is a stressful exceedance level for an aquatic organism? If this goes back to some of the scale at which we're evaluating these exceedances. We decided to use the unit value data instead of trying to aggregate. We did do those and how we've got some hourly and daily exceedances. So if you have 96 values per day with a 15-minute interval, if you have one exceedance, fall below 6 milligrams per liter one time, using the unit value data, that's disproportionately less, proportionally less influence than if you say, all right, on a daily level, so if it falls below 6 one time during the day, that entire day is considered an exceedance. So the scale at which you interpret this data is really important, and we did go through some routines looking at the 10% using those different scales. We decided to go with the 15-minute because the hourly mean versus the unit value 15-minute mean were no different. There is going to be differences if you compile data into a single day. So if, again, DO falls below 6 one time, one 15-minute interval, you can classify the entire day as an exceedance. That's really going to affect the 10%. So we went with the finer scale because, a 15-minute interval, if there's only one, again, per day, is that really stressful to an aquatic organism or no?
Right. Yeah, and I understand, and part of the weakness here is any exceedance is treated equally. So a 5 part per million is treated the same as a 1 part per million, whereas its effect on the aquatic boat is going to be significantly different. And so that's why I'm trying to focus in. When is the most critical time you need to do that assessment to make sure you're being protective? And since you're not being able to unequally weigh a 5 parts per million versus a 1 part per million, the way you do it, the way you focus in on the times where if you're going to get that 1 part per million exceedance, you're measuring it. You're out there in the water, you're grabbing that sample.
I'm Sean Hodges. There's additional dissolved oxygen criteria labeled in the nutrient section on page 46. And there's 4 water quality translators. They're dissolved oxygen fluctuation, dissolved oxygen concentration, dissolved oxygen percent saturation, and the other one's pH. And my question, I guess, to be brief, is there a way to calculate the percent saturation using the USGS continuous data? Yeah, that's for Billy. or Luke.
We'll let Billy tackle that one.
okay, I was looking the whole time. I was looking for what you were trying to read me. So.
Here, this is the water quality translator for the nutrient, to list as a nutrient impairment.
The main question is SAT. Can you do it? That's just this question.
Because we have fluctuation, that's easy. Max, min, and then
You should be able to calculate SAT.
and then can you calculate percent saturation looking at the chart of pH and DO, and then Luke has talked about, well, DO drives pH because of photosynthesis and then respiration, you'd automatically assume there's going to be a correlation just because of the relationship. But can you tease out if there's a nutrient impairment that's causing, or a groundwater influence, or can you use percent saturation as a way to tease out which one is groundwater and nutrients? We could take a break, do you think?
Well, to an extent you can, but I mean, to an extent you can, I mean, we need barometric pressure really to get at the saturation. You know, we could assume a barometric pressure and get close probably, but we have looked at, you know, like in the case of the variability near the low end that's associated with groundwater, you know, the question came up, would it be more straightforward to use high end variable where you have supersaturation and say, if you're going to see this much variability and it gets to this point, in a situation where you knew you had groundwater influence, would there be, you know, that's just something we've talked about between us, is that would be that, but that's a decision for ADQ. It's just.
And this is Randy Easley.
Had to figure out where that was coming
Where's
from.
that coming from? You know, excuse me if I'm wrong, but I know the multi-parameter probes that you guys had, at least demonstrated up there, displayed, most of those already collect percent saturation and barometric pressure. Isn't that correct? So that data is still available if you had some way to crunch it to answer that question.
I know it's an option, but whether we would set whether those monitors were set, we may be able to, see, you could go back to the monitor, but if those data are just downloaded, there's probably still not available. Yeah, absolutely. We could get that information forward if we'd known it was going to be used.
So we have had really good discussion, and thank you, Luke and Billy, for coming today, presenting that, and answering the questions of the stakeholders. We appreciate that, and again, thanks for everybody who had questions. And what we're going to do is take a break. We should have taken a break, about 30 minutes ago, but we were doing well and discussing vigorously, so didn't want to stop the discussion. So let's go ahead and say at 2:20. We'll come back and we'll move on to the next section that we had allocated for 150. Thank you.
Okay. All right, we're just checking to make sure our recording was back up. All right. I think we had a very good discussion with USGS over their study for continuous DO monitoring. Our next topic on the agenda is to kind of further our discussion on how we're going to assess the continuous data, not just limited to dissolved oxygen. And the first point of input received was on section 3.2.1, and that's going to be on page 2 of the summarized input, and it's the comment from the National Park Service. So we'll pick up right there.
All right. So just the this is the compiled comment specific input. If you can, if you have that in front of you. Again, it's on page 2, 3.2.1. Two things. When you do talk into these the lapel microphones, if you can hold them a little closer to your mouth We've been listening back on our recording, and it's just not coming up like we would hope. And also, I think it helps the folks on the phone as well. So if you just remember that, it's a little small thing. And then also, I just wanted to say thank you to Colleen Gaston, who's not in the room right now, but she has graciously provided the scones, I believe, in the back. So we want to say thank you to her, Colleen, though you're not here. So if you run into her, say thank you. We didn't even ask her to do that, and she just did that. So the next person in January, feel free to just throw that out there. But getting back to business. So it's from the Park Service. Table 1 states that continuous monitoring devices and continuous monitoring would be used for assessments. However, when mentioned during the 2016 listing period, ADQ stated they weren't able to assess continuous data for listing purposes. I do believe, I won't read all of that. So if you look in, you were talking about the, if you go to your assessment methodology, I'm not sure we need to just dig into this, but it's that the matrices in the front, I can find them. Where is that, Mary? Page 12. So it's really it's on page 13, or on my page 13, where the hierarchy of data quality levels for assessment use is. So you do see that there is it does talk about continuous monitoring. We did not have a methodology in place during the 2016 assessment period. That is the reason that we had USGS look at this issue for us, so that we believe that resolves that comment on that front. So I've got so many sheets of paper. So let's look at discussion of continuous monitoring data, 6.2 for turbidity. Well, do we want to? That's on page. That's on page 9 of the comments. Mary's telling me. (6.2) turbidity. Which page on the method? Page 34 of the methodology. But as it relates specifically to continuous monitoring, with turbidity, well, okay, so this revisions are needed to conform with the recently approved. So we're changing as it relates to this comment that you see on page 9. We're just going to change, this is a Reg 2 issue. We're going to change the title of all flows back to storm flows, which it was originally prior to us changing it back to all flows. So we are going to make that change. But then let's look at the continuous monitoring. Looking at the continuous monitoring and how to utilize and evaluate continuous monitoring data for turbidity. So one of the big issues with this is that we have USGS has continuous turbidity monitoring at certain locations. The data that is collected is measured in FNUs. Our criteria is in NTUs. Okay, and those aren't always the same. So the FNU stands for is it FEMTA? What is it? I forget. Formazine, nephelometric turbidity, that's NTUs, nephelometric turbidity units, and Formazine turbidity units. True? Okay. So they are different. Therefore, that is a large issue for, we've talked with EPA about this one issue, about utilizing NTUs, FNUs. Are they the same? Our criteria is in NTUs. Can we use the FNUs? We need to develop a criteria in FNUs, is what the information that we've received from EPA. So we wouldn't be able to utilize that data. We would be able to utilize it for screening purposes if we wanted to do that, but we wouldn't be able to make assessments with that because of the unit is not the same. Anybody want to add to that? Yeah. Or, I mean, also, is USGS, do you want to add, or Tate, did you have anything to add? But
Is there
yes.
not a translation table where you can actually use the NTUs translated to FNUs? Do I have that right?
No, the short answer is they do relate on a one-to-one relationship. On if you were to plot FNUs to NTUs, there would almost plot one-to-one up until about 400 NTUs, which that would exceed the standard. But if you talk to any person that really studies turbidity, they're not really appropriately. They're not synonymous terms or methods. The FNU method is for drinking water standards. That is why USGS has done that, is for protection of drinking water. The NTU has historically been used for the protection of aquatic life standards. So the next step is really developing a strong correlation between FNUs and NTUs in Arkansas across all of our data that we collect, and show that there is a correlation between those to develop a standard. So that's the next step.
Go.
Have you given thought to, if you in fact, so you have to change the standard, right, in Reg 2?
Well, first you'd have to look at the correlation between them and find out what the appropriate criteria would be, and then you'd make the standard. But we definitely would have to, in order to utilize, currently, right now, we feel like in order to utilize the continuous data, I mean, we can't. That's the position that we're in now, we feel like.
Okay.
Does that make sense? What
Sure.
was your question?
I didn't know if you were trying to go ahead and make decisions about future use when the standard was changed, which I assume is going to take several years if you change the actual criteria.
Yeah, you would have to, yes.
So really, it's just for this assessment cycle, it's just a question of you have the NTU standards or criteria, and what data you have that can be used against those
Yes.
criteria, which is not the continuous monitoring data. Is that what?
Yes, but I mean, we would be. The thing is this: I always want to say that if we do see that there's a potential turbidity impairment or turbidity issue, then we would want to focus efforts on that. That's all. We would certainly use it. I don't want, and I guess this would be something that we would want to say throughout reviewing all data, not just turbidity. But if we see data that indicates there's a problem, we would want to investigate more. It's not that we're dismissing that or not even evaluating it. That is not the case. That is not the case at all, and so it hasn't been. Anything else on that? Turbidity, anybody? Okay, awesome. Sorry, I wasn't going to say that. So let's look at. We did turbidity. 6.3 is pH. So, Mary, let me ask you this on a procedural note. We have the compiled comments of 6.3 in the compiled comments, but yet we still have but we're really discussing the continuous monitoring. So I'm going to stick with the continuous monitoring discussion with pH. You okay with that? What's that? Yeah, okay. So let's look at pH. So there are stations. You probably have. Let's think about USGS and their continuous monitoring for pH. Probably, of course, there's the gauging stations. As far as pH, how many more monitoring stations, pH compared to dissolved oxygen, do you have more, which ranks out higher?
We have stations that have only dissolved oxygen and temperature. We have temperature pretty much everywhere. Conductivity and temperature are our two most common constituents. If I was guessing, I would say we might have pH at 12 or 15 sites, something like that.
So we evaluate our pH data. There's a 10% exceedance rate for pH for our single grab samples that we have. So normally we'll have 60 samples for one station in a perennial stream. So we're going to be collecting monthly over for the 5 years. So there'll be 60 data points. And so there's a 10% exceedance rate that we apply for pH. So we would have, we were looking at continuous data. We would, in internal discussions so far, we've thought, well, what about 10% for pH as well, in addition to DO, evaluating it at 10% as well. There's only 12 to 15. You're squinting, Billy.
I was thinking.
Okay. You have fewer with pH. Oh, 10, okay. You want to say something? Nope? Okay. Anybody else? Ryan has a question.
Make sure, and maybe I missed it, and
Well, I think that goes back to something that, I don't. I'm trying to really think about actually like sitting down and doing it. I know, yeah. Well, I feel like you're trying to do that to me too, so it's okay. We would have, you would have the, Mary has an idea. I don't know what you're saying, Mary. So what I'm thinking, so we'll have 24/7, right? We'll have 24/7 of pH. That would better describe what's going on. The pH is there to protect the aquatic life use. So you have 24/7 every 15 minutes. Is that true for pH?
We have 10 sites.
But is that normally done? I don't recall. So it's every 15 minutes.
At those 10 sites.
Okay. So we have every 15 minutes monitored. That would be a better description of what's going on, a characterization of what's going on in the stream. So you have a 6-month period. You wouldn't have an entire seasonal breadth. I'll quote 4 seasons as we're having them now, I guess. But so I think that would be a better descriptor. So we have to figure out whether do we want to if we have an adequate amount of continuous data, are we going to fall with that? Are we going to fall with that data set? We just can't. We have to include the single samples. Mary has there you go.
So just to kind of throw this out there to the group, for our bacteria, we assess based on the primary standards, and we also assess based on the secondary standards. And if either one of those assessments points to an exceedance, then there's a 303 delisting. The same for turbidity. We have base flow and storm flow standards, and if either one of those has an exceedant, is exceeded, then there's a listing. For DO, it's primary season and critical season. So I could see the opportunity to be similar with if you have continuous data and discrete data, if either one of those showed, the 10% exceedance. I guess what is the group?
I'd have to agree. I mean, we're calling it, Mike Armstrong, we're calling it continuous data, but it's not. It's still discrete data. It's just at 15-minute intervals. So you'd have to treat it equally. You have discrete data collected at monthly intervals, and then you have discrete data collected at 15-minute intervals. So if you have a 10% exceedance rule, it shouldn't matter whether it's based off 15-minute intervals or 1-month intervals. It's still an exceedance.
I guess my counter to that would be, though, you're looking over a 6-month period, and the way you assess is over a 5-year period of record. So over that 6-month period, using every 15 minutes, that you're going to almost all, I mean, I would assume you're going to be impaired because 10% over that period will overwhelm the other 4.5 years, right? The other 4.5 years, that data will be worthless because you're going to have so much every 15-minute data. And if you're considering them in the same pool and pulling out 10%, then, so, I mean, I don't know if I could do the math on how many samples you're going to get every 15 minutes over 6 months. But we know how many you're going to get over the other 4.5 years, and that is, 54.
But it still goes back to if the premise is the standard is established to protect the use, then an exceedance is an exceedance.
Sure, but so this is the scenario then you're going to get into, in my opinion, is so I'm assuming you're going to do some sort of special study and you're going to grab 6 months worth of data. You may not go back and gather continuous data again. So all you're going to do is wait until that rolls out of the period of record and then the stream's going to be unimpaired again? See what I'm saying? So you're using a 5-year period of record. And so every year, 1 year drops off and 1 year gets added, or every 2 years, 2 years drops off and 2 years get added. So if you call something impaired because of a 6-month continuous set, sooner or later that 6 months is going to fall off and the stream's just going to be unimpaired again. Well, if the discrete samples are showing aren't showing more than 10% exceedance.
If you follow, but you have to look at the delisting methodology. So there's a listing methodology and there's a delisting. So it's not just automatic.
So that leads to the next point, though. So what it means, though, is that you might have a stream that stays listed forever because you don't go back and do that same level of independent of study. So you can't get it off the list without going back and doing 6 months of continuous data, which you might not, someone may not do because whoever collected that data was doing it for a discrete purpose.
Well, the real issue is all the error that's associated with the time of day that you're collecting that one sample per month. That's where the real error comes in, because if you're going to collect it at 3 p.m. every day, you're not going to have impairment for dissolved oxygen. But if you collect it at 6 a.m. every day, you might, or once a month. So I think that's where the real error is. I mean, if a statistician looked at that, they would probably say, don't even look at these discrete numbers. Look at the continuous data because it's going to be much more representative of what's really going on that stream.
No, I don't disagree, but the amount of areas where we're going to have continuous data is next to nothing. I mean, and the resources just aren't there. I mean, we don't have it in natural resources to do. We do some special studies, and this is where I'm really worried about. We'll go in and do a study. That data will exist, but we're not going to go back. We don't have the money to go back continually and do continuous sampling at sites forever, and no one does. So, something I said at the last meeting is true, and that is all assessments are wrong. They're just what you get, because the only way to make them right is to do continuous sampling everywhere, and you get that. So it is what you get. You get one sample taken on one day, and that means you're going to have streams that are listed that aren't really impaired, and you're going to have streams that are listed as unimpaired that are really impaired because of what happens on those days. But it's what you've got. But I just don't think you can I don't think you can just match 6 months worth of continuous data in with 54 other samples and use a general 10% rule on that. That just doesn't, I mean, to me, that just doesn't seem, I mean, I don't think the statistics on that would work either. Now, the 6 months of data is maybe the more valuable of the time period, but you need to replicate that all year long. I mean, you need to do that all year long if you're going to count that data.
But you can solve that problem. How other states have solved similar problems like that is they just take one measurement per day when they have continuous data, and it's the lowest measurement that characterizes that entire day. So there's a lot of different ways to kind of handle this.
Again, that's only when you have continuous data.
That's true, but at least it matches up a little bit more.
This is Sean Hodges. The main reason I made that point was just to draw to light that there's a lot of times in the 2016 assessment methodologies that require listing via continuous data. And there's a lot of times that the data does not exist in order to list a system based on that. And so if it's available, that's great. But if there's data not available, or like Ryan's saying, if you go out and you just collect a certain set of data, it characterizes that system for that time frame, and it may be impaired at that point, but there's a lot of data that's collected that will never list a system because it's discrete samples, and it takes a 24-hour fluctuation in order to list it. And so I'm not sure how to change that in the assessment methodology, but if it's never a possibility to list it, then to me, it shouldn't be in the document. Or it needs to have caveats that will apply to, okay, we have a continuous data set in Ryan's case and say, okay, I have 6 months of data. This was a special project, and we do have an exceedance. But does that characterize the past 4.5 years that this data exists? And so in there needs to be some kind of ability or control within the document that says ADQ has the ability to say, okay, we've gone out and used discrete samples or some other methodology that will allow this system to be delisted.
There might be a happy medium there. I mean, continuous data, the data that were used to develop this Arkansas standard were developed in the 80s using 72-hour data. You know, if you look at 72-hour data, so you get 270 points over a 3-day period. If you do that 2 times a year, then you got a lot of points. And you only probably got, 2 times the amount of manpower it takes to go out and get one discrete sample. I mean, as far as the actual data collection effort. So it seems like there's a ton of, it's still continuous data, but it's on for a much shorter period.
So, okay, that makes me go back to Mary's offer, or Mary's thinking, Mary's thought, which is we have then our sampling, our normal sampling effort, which is like once a month. But then, say for the same area, we have the 6 months. Why not say if you exceed during these 6 months, and whatever appropriate data quality objectives are in there and everything. So what if you exceed during that 6 months, or some type of continuous monitoring under certain conditions, then it is exceeded, and then with these with our monthly samples, this is how these will be evaluated and determined as impaired or not impaired. Is that what you're thinking, Mary? Nope. Okay, so you would have to qualify it. So, like, you'd have to have at least, you'd have to have at least a certain amount. Like, you'd have to have at least 6 months of data, or you'd have to. How do you evaluate that 72-hour? What we normally would do is 72, 96-hour time period. How do you evaluate that and say it's impaired? You'd have to have you would have to have perhaps a different set of criteria for that 72-hour versus our normal monthly sampling. Have different set of criteria, but at least clarify how those are going to be evaluated. Whereas it seems like you're saying it's not clear how it is evaluated or if it's going to be evaluated and so on. That, right, Sean? No, that's not what you're getting at. Okay. Concisely describe how to evaluate that continuous data versus the other. Would that answer the question, or I'm not, anybody? Brian? It is, it's green and red, it's a nice Christmas color.
So, no, to me, there's three scenarios, and two are easy and one's very difficult. If all you have is discrete sampling, it is what you got. It's not what we'd want. We want continuous everywhere would be great, but that's what you got. You have to evaluate based on what you got. If you have continuous for the period of record, hey, it sounds like from the presentation earlier, using the same method of exceedance would work for continuous data over a complete period of record. Those two sounds like solved. Figuring out what to do when you have to use both, right? When you have to mix them for a period of record. And once again, the two things is, one, figuring out how you get it listed, the other, figuring out how you delist it if you're not going to go back and collect continuous data. Obviously, from natural resources, our 319 projects look to delist streams that get on there, and we need a clear process for determining that we're going to be able to take, we're working to take streams off the list through improvements, to make those requirements. So that's the thing, is just figuring out how you're going to mix them. And the way the standard reads right now, it could be interpreted, you're just going to add it into the big pot. You're just going to throw those 48 in with the 5,000 other samples and look at 10%. And to me, that's not a representative way of looking at it. But yeah, I think you just have to have some way of doing that if you're going to consider continuous sampling when you don't have it for the entire period of record.
Right, yeah. Which could easily be you have to assume that that's going to happen. You have to figure out how we're going to deal with that.
Actually work here. Sorry for standing.
Green means go, red
Don't
means
touch
stop.
it.
Okay.
Okay. The pH standards for Arkansas and many other states weren't made or decided upon based on ecoregions. They're literature-based. There are natural places out there, as we're finding out in the Washtals, where the pH naturally drops below 6. That doesn't mean it's impaired or not meeting criteria. The standards are also not set based on 72-hour or diurnal fluxes. We actually don't have pH standards to address 72-hour monitoring. The first thing we'll have to do is go out there and spread data sondes all across the state and actually come up with a standard so we can assess against it, if that's what we want to do and if we can find the resources to do it.
Yeah.
There's another monkey wrench for you. Thank you.
We have to, so as it relates to the 72-hour, I think I feel like we've gone through, I feel like we're at a point of how do we, I think you're right, Ryan. We're at a point where we can evaluate the continuous independently. We can evaluate the discrete samples of monthly samples independently, but how do we do that together? That's something that we're going to need to. What I would like to do, I'll just put this out there. Billy may have an idea, but because you're holding the microphone, but what we may need to do is to come up with you guys can go and contemplate that, but we may need to contemplate that ourselves here at ADEQ, come up with a recommendation for the group about how we would like to see it, and of course have open discussion after maybe you guys have thought about how to deal with that too. But for the January meeting is what I'm thinking right now. So go ahead, Billy. What do you have to?
It would appear to me that we could just do a simple ratio of the time period of the period of record that each one represents, and apply that. You know, if it's 11% during exceedance during the continuous monitoring and it's 9% during the other, and you see how that all meshes up as far as the percentage over the period of record, so that shouldn't be that difficult to come up with a reasonable number that would truly represent what you've got for that period of time.
Mm-hmm. Well, that's nice. Okay, that's good. That's an idea. And by the way, we're capturing everything that we say here. So.
And Ryan, I'm playing a little bit of devil's advocate because I happen to actually agree with you. It's hard. I couldn't rationalize waiting so much towards a 6-month where you got 1,000 plus samples versus, you know, another 4.5 years where you got, 48 or something like that. I think what the variable we're dealing with here, and you're going to have to go back to, is the variable of time, that one monthly sample represents 30 days. And so you assume that if you went out in that 30 days, you would get that same value on the day that you went out. Now, actually, we know that's not true, but you're going to have to make that assumption. So you have to take a look at that continuous data and do the same thing. You have to break it down into 30-day segments and then apply some algorithm that states that if I have an exceedance, what amount of exceedance would I say, okay, you know, that's too low of a threshold. I shouldn't give that 30-day segment an exceedance and weight it more than I would a monthly sample. Or, you know, at what point will I? And it might be the 10%. So if you have a 30-day continuous monitoring, if 10% of your samples exceed, that might be, okay, I'll weight that the same as if I went out one day and sampled and got a 10% exceedance. I mean, you're going to have to weight. You have to bring the continuous monitoring and the 30-day, 1 day a month sampling on equal terms by using some sort of decision algorithm that you're going to accept some amount of exceedances on continuous data and have a threshold at where it says, okay, it's above, I'll count that as an exceedance, or it's below. You do it now on your 10% taken one sample every 12 months. You're just making the assumption that one monthly sample is the same throughout those 30 days. I'd go out any other day during that 30-day period and find the same thing. So you're going to have to do the same thing on the continuous monitoring. To me, that seems like to give equal weight on the time variable, you're going to have to come up with that type of a protocol.
Okay, thank you. I think what I want to do is hear what everybody has to say so we can.
Could I make a recommendation?
Yeah.
So, you know, I think probably other states have had the same problem, the same challenge with more and more continuous monitoring systems coming online. And I'm pretty sure they've probably gone in and done some statistical review and had the same discussions that we're having right here. So I would suggest that maybe we could go back and look at other states, see what they've come up with, and take it up at the next meeting.
Okay.
You're right. The Association of Clean Water Administrators have compiled a list of all the states that are using continuous dissolved oxygen, particularly dissolved oxygen. I don't think they address other parameters, temperature or pH. We can provide that summary. I think it shouldn't be a problem to put that out to the listserv for everybody to review what these states are doing. It's a simple table of what the states are doing, whether they look at DO minima, average hourly, and how I think there should be links to how those states are assessing those concentrations. Sarah advised me to bring it, and I forgot to grab it I just forgot to grab it. But I think that's a good summary of what everybody is doing.
Teresa Turk again. Do they also assess, or do they do they have a recommendation about how this discrete data with continuous data? Do they have any kind of recommendations like that?
I think so. In the actual document, I don't think they. Anyways, no, they don't provide a summary of how they're handling the two separate data sets and how they're trying to combine those. They might in each state's assessment methodology, but the
Association of Clean Water Administrators did not provide that information.
Does anybody else have anything to add to the discussion for this continuous data section? So it seems like what we have is we're stuck with this point that we of how to look at the continuous with the discrete. So what I'm hearing is that we're going to go look at other states, see what they're utilizing and how they're handling this conundrum, and get back with the group on the 12th date or thereabouts, that 1st January date. Is that a good synopsis of our continuous data discussion? Anybody else want to add anything? We are going to try to move back into the schedule, the agenda that we have, and take another break and have another scone. And the maple scones are really good. Okay. So I apologize. The folks that are not here are not going to be able to enjoy that. But so let's go ahead and stick with our break for 10 minutes. So 3:10 is when we're going to come back, and we're going to start. I believe nutrients is the next item on the list. So thank you for a good discussion.
Our discussion on nutrients, and just to help you follow along, in the summary of input received, the nutrients input starts on page 10. And in the 2016 methodology, the nutrients methodology starts on page 46.
Mary, quick question. So one of the comments that I submitted to not everybody in the work group, but to ADQ, was that we consider the 10% rule as we go along on the individual parameters, which I guess ADQ decided not to do that. But I just want to, say that, for example, we talked about turbidity. I would like to come back to it on that issue, again, whenever you guys schedule that, but do not want to forget that turbidity is one of the parameters for which there's variance from the 10% rule. There's a 20% and a 25% exceedance for assessment. So that's just...
And I think it is the department's intent. The way the methodology stood in 2016, there was kind of a blanket discussion at the very front, like the very front of the methodology that said, that 10% will be used, and several other data use requirements were in the front. And it is our intent, so as to make it more clear, to have the data use requirements for each, in the specific exceedances and all that, for each individual parameter to be listed with the parameter in the methodology, like section by section. So hopefully that will clear up some of how the data is used for each parameter. I'll clear some of that up.
That's not completely my issue. And again, I'm just saying we're postponing this to another time. Mine is, what is the explanation for that variance from the usual 10% rule? So we're going to have to go back and talk about turbidity again instead of doing it all, turbidity issues all at once. We're going to come back to it when we're talking about why is it not 10% of the time that puts it on the 303D list.
We can.
Okay.
That's something we'll take that up as we go back through the specific standards, as our sessions continue and we start to get into the specific standards. Then we'll bring that up, and we'll dig in and look at the history of the turbidity criteria and the exceedance rates that have been applied. So we'll do that. So let's go through I'd like to go through the comments as it relates to nutrients. So that is 2.509, I believe. National Park Service, a recent Creel survey by Buffalo National River and Arkansas Game and Fish. Notice increased river use outside of the defined primary. I'm sorry, jumped up. Sorry about that. Let's go down to 6.9 and start into bacteria. Don't want to do that yet. That's not the next thing on the list. Okay, sorry about that. Under listing methodology for weightable streams, the first bullet represents a shifting baseline for nutrient comparisons. A major assumption of this criterion is that surrounding sites within the same ecoregion, sites used for the computation of the 75th percentile values, will not experience similar increases in nutrients. Comparing sites among themselves during the same time period removes the ability to document slow increases in nutrients over time, both short and long term. Figure 2, for example. Maybe I got the wrong lapel mic. So this is a comment that we received with a letter that you guys had sent, that October letter. I remember that now, right? No, this was a comment for this one? Okay, specifically, okay. So there's so in figure 2, for example, shows a spring within the Buffalo River, which has experienced a 300% increase in nitrate concentrations at base flow over the past 25 years. If this site were used as a comparison for other segments or water bodies, it would be possible neither site would be listed if both sites experienced similar increases. So just let me try to answer this, and if I miss anything, let me know, Sean. But so the screening values are developed, and this is the first part of our evaluation and conducting nutrient assessments. So that's on page 48. So we have this screening criteria. How we develop that screening criteria, I may get this wrong, but we look at all stations across the Ozark Highlands, across all the Ozark Highlands, Boston's, all the ecoregions. We look at total nitrogen and we look at total phosphorus. And from that, we develop an average. Is that right, Dave? We develop an average, and then, no, that can't be right.
So we take the 75th percentile of all available data for the period.
I got the right mic, yeah.
So we take all of the available data for the period of record for a given ecoregion and calculate the 75th percentile for that ecoregion and for the screening value. And then for each station within that ecoregion, we average and compare that to the 75th percentile. That's how we assess to get to basically the second stage in that flow chart.
So that's what we do. That's how across all the stations that are in our ambient network, we utilize that data to develop these numbers. So
I guess to that point, since there's no numeric standard set, and you continue to add nutrients to a system or watershed, and then you continue to rotate those through a 5-year cycle, you'll never capture an increase in nutrients over time for an ecoregion if you continue to just base it off the 75th percentile from the last 5 years. Is that correct? Since there's no numerical standard set, then as nutrients accumulate over time in a watershed, and then you keep going back and just using the 75th percentile from the last 5 years, a slow accumulation of nutrients in a watershed or a ecoregion will never be measured.
So you're saying we're comparing it as we go throughout the 5 years, we're potentially, with the assumption that nutrients are always increasing, then we're constantly comparing it to degraded condition.
So the condition continues to degrade, but since you're associating it with data that's in I've got a green light.
Yeah.
Yeah, so it's a shifting baseline syndrome,
Right.
and there's a lot of fisheries papers written over it that since there's no standards set, and then you keep reapplying it, but you keep moving the time frame forward every 5 years, then what the standard would have been based on numerically in the past continues to increase. There's an assumption made there.
It's not a, well, okay. This is just the screening value we're talking about. I mean, this isn't the, granted, it pushes you into this decision tree and certain actions to be taken, but it's still just this is just the screening value to take essentially the high end and start using that as, where do we focus our efforts? Because we do have a narrative nutrient criteria, and it's quite involved. Okay, we're going to follow through with what the narrative says. We believe that we've captured that in this decision tree right here, but that takes a lot of effort because we don't have numeric criteria yet. But we're doing the best we can. So, I mean, it is just the starting place. But if I'm capturing what you're saying right, you're saying that we are, just by doing the 75th percentile as a screening value, you believe we're missing.
There's a potential.
Missing those streams that should be plugged into this decision tree.
Which there is a potential way to look at that is if you go back and assess the 75th percentile over the last 6 to 7 assessment methodologies that you looked at, does that percentile increase over time?
Well, I think it really depends on the data set that you have at that time and the site sampled. And so in your example, you did see increases over the last 25 years. For some of these sites that we have 30 years of ambient data, looking at trends in those sites, or just, not really a trend analysis, but looking at long-term data in those sites, a lot of those sites stay pretty stagnant in their nutrient concentrations. That you don't see large fluctuations up or down in the larger systems. Again, I agree that depending on the given period of record and the sites sampled during that period of record could drive your 75th percentile up or down. It just depends on the site sampled. But the way ADQ samples, we generally go back to the same sites over and over and over time. So I do agree that if something is happening, we could miss it. But the idea behind the 75th percentile was we're going to focus our attention on the most likely to be impacted by nutrients sites. And so with that 75th percentile, you're going to the worst of the worst, and you're going to drop into the tiers. If the nutrients are impacting dissolved oxygen, pH, aquatic life, that's where we're going to see it, and that's how we interpreted the 2.509.
That's good. I guess the other question that would tie into that is when you create your numerical standards for nutrients, I know you guys have been working on that, and that's not an easy task. Would it be possible to base some of those standards on the systems that you know long-term have not increased in nutrients so that you're actually capturing a non-altered state or a more pristine state for that system?
There are ways, and then EPA calls it the historic condition approach. Basically, you're setting criteria or developing criteria on the historic condition of what the values should be.
Well, there's different, we could use that reference. One could use the reference, or you can use a gradient. There's different approaches. Okay, did that address your comments essentially in this? Yeah. Okay.
If it didn't, I'll come back.
Okay.
I have a question
Yes.
on what Tate just said. So, Tate, are you saying that so you're taking all the data for an ecoregion from weightable streams, but you're saying those are the worst of the worst?
Not really.
No, depending on, so generally we have our ambient stations for an ecoregion. Those are going to be sampled on a monthly basis. Depending on the department's or planning's rotation through the state, we may be in an ecoregion, and that could increase the sample size in any one direction, plus or minus, in the nutrient gradient. What I was getting at was the 75th percentile was to focus on potentially
impacted sites already. So if it's less than 75th percentile of that TP and TN concentration, there may not be a nutrient impact to aquatic life. So once we get over that 75th percentile of the entire population of the nutrient gradient, you're more likely to see an impact to aquatic life. So why spend resources on something that may not be affected by nutrients?
And
May or
maybe
may
I'm
not.
confused, but typically, though,
That's for setting criteria. And so what EPA says is the 25th percentile of all available data or the 75th percentile of least disturbed. Now that is for setting criteria, not a screening value to determine nutrient impacts.
but it seems to me that that would apply. I mean, that you, if you're,
Well, again, there's no guidance in for setting screening criteria for where we need to start evaluating nutrient impacts. Again, this was a starting point. It was always intended to be a living document. And until we have numeric criteria, this is one of the best things. And if we limit to the 25th percentile of all available data or the 75th percentile, we may spend unnecessary resources for those median or mean values of TP and TN that may not be necessarily nutrient impacted.
but the converse of that is that you're setting the first, I mean, Sarah's saying this is just a step in the decision tree, but it's actually a hurdle. If you don't get past that, then you don't look any further. So to me, you would not make the first step in the process be more likely than not to assume everything's okay. You would do the converse of that, which means you would either use the 75th percentile from, pristine or least disturbed streams, or the 25th percentile from the entire data set. And then you have further steps that you could then decide, well, is it truly impaired or not? But you don't just automatically throw it out right off the bat, which also would address, the Park Service's issue that they raised in terms of sort of drift overall in the data set. Just a thought.
So I know we're talking about assessment methodology, but I'm assuming that the department then uses those streams that get past the first tier, but then are insufficient data to prioritize places to take additional data. I mean, this is
Yes.
You don't have this much data for most streams. And it's just, this is expensive data to collect. The second tier here, or third tier. So, I guess I understand what you're saying, but I think where you have, it's kind of approaching the worst streams first scenario. Screen it. If you have the data, you make an assessment criteria. If you screen it and it gets into but you're in the insufficient data, I'm assuming you guys prioritize those streams for data.
Yes.
Right? So you see what I'm saying? I think there's a dual purpose to this methodology, and I guess I'm a little biased because I was here when they created it at the department. But it was two purposes. One is that you have to have a way to assess the narrative criteria. Selena over here requires that. And so this was a way of trying to figure out a way to assess a narrative criteria, which is obviously very difficult. So while we're talking about it, numeric criteria, though we've had some issues with those on the previous discussions, they're easy compared to a narrative criteria. But this was as much as making an assessment determination, it was also a prioritization of where you needed data so you could even make an assessment determination. That's my understanding of the methodology.
That's true.
Yeah, and I agree, Ryan. I don't think anybody's disagreeing. You need some screening protocol. It just seems like, as Colleen said, that it's a hurdle to get to that next stage, that the error is going to be you have impaired streams for nutrients that you're not able to do the assessment because you've got such a high hurdle on the front end to even make that decision, that 75th percentile. And I think the point that Sean was trying to make of the potential for drift of the data over time, because you're not fixing it. You're using the last 5-year period of record rather than a previous time period that, again, you're making the assumption that is least disturbed or least impacted by nutrients, so that you're not making the error of chasing a moving target all the time. That's going to mask the screening.
Sure, I see that. The only thing, when I was hearing that discussion, the only thing I was thinking though is they're taking the 75th percentile of an ecoregion, not of a, so to get that drift, you're assuming you're having this increase in nutrients across an entire ecoregion of streams that the department samples, including a lot that are very unimpacted by any activity. You see what I'm saying? So to have that concern happen, you would have to assume that we were having something going on in an entire ecoregion that was causing all the streams to increase in nutrients as a drift up, which, I mean, I think what I heard Tate say is we just haven't seen that. Now, granted, the ultimate goal, I think, for the department's working on is eventually to have good, defensible numeric criteria, which is a higher hurdle than coming up with a good assessment methodology. But I think I see the chance of the drift being very minimal, considering you're looking at an entire Arkansas ecoregion of data.
And I would agree, but 2 points. One would be you don't know if you're doing. I mean, Tate made the statement we don't see it. But it goes back, is that part of the evaluation? Are you making sure you're going back and doing that checking? No, we are not seeing, because nationwide, I mean, EPA said that there has been an overall increase in nutrient impairments and nutrient levels nationwide in streams, and we're seeing it manifested in a lot of different ways. The Gulf of Mexico, dead zone being one, the classic example. So I think it would behoove the department just to error check itself.
Well, and so what I'm going to do is probably this afternoon. So we've only ran this flow chart for 2 cycles, 2014 and 2016. That's what I was visiting with Sarah. She brought the 2016 screening values. So we'll do, I feel like I did this for another presentation, but I don't have the 2014 values in front of me. So we can look at and compare the screening values for 2014 and 2016 very quickly, because we have those already available. So I'll send that out. I'll send it to Mary and have her send it out to the group. Right. But and again, it depends on the data set that we sample during that period of record. If it's more least disturbed samples or more of a probabilistic design, that's going to sample the entire gradient. And so it could be that if we focused more on nutrient impacted sites during a survey, it could be that it drove the 75th percentile up. If we focus more on least disturbed conditions, sites that are least lower nutrient concentrations, it could drive that 75th percentile down. It really just depends on the sites sampled during that.
But we can do that. We can go back and look at any type of, and we can go back and look at, I mean, a lot of these sites will have over 10 years of data on. We can go back and look at that too. So, I mean, it's not, we can do that. Right. And we can report back to you guys on that.
And I'm not surprised you're not seeing it a lot, because it's going to be very site-specific, and it's going to average out over an ecoregion. I remember in the Arkansas Water Plan, Kent Thornton did an analysis, a period of record of everything we have on water quality, and nutrients are one of them. And some of them went down, some of them went up, but overall it looked pretty static statewide. So I'm not surprised at that. My other point being is that 75% is high. In my estimation, as a screening value, because you could, again, my fear is you're missing an impact on these other criteria on the chemistry and the biological life that you're never going to be able to assess, because you have a 75 percentile bar. And that is purely arbitrary. I don't know what it should be. Should it be 25%? Should it be 50%? I would argue for a lowering of it so that you are at least giving comfort to us that are worried about nutrient impairments, that we're missing things that are occurring, but we're not getting them because the screening screens them out before we even get an opportunity to look.
Well, I mean, we could, I will say this, we're open for recommendations on that point. Okay, if that is yours, we will write that down. I think Jesse got that.
And there have been there were comments recommending 25%, or either 25% of the entire ecoregion or 75% of pristine reference streams. But just to address Ryan's point, which I understand. I mean, I have before said we got to be practical in terms of how much data is out there and can be collected, but I don't see, this is just a paperwork exercise, the first step. So it's a matter of crunching some numbers. And to me, if the pool of segments, water bodies that goes down, you say yes to, they exceed I'm going to change it to 75% of pristine streams, or you could do the converse of that. But you have a bigger number of streams that you look at to see if you've got the further data to make the evaluation. And for a lot of those streams, you're going to find out, no, we don't have that data. But you may see some streams on there that surprise you, or that just got kicked out originally. And so somebody may say, oh, well, I see that in terms of just the in-stream concentrations of nutrients, that it looks like there could be an issue here. So for whatever reason, I'm going to try to get the resources to do additional data collection to be able to go further down the decision tree. But again, to me, it's like, why wouldn't you open the funnel a little bit at the top, and then you can narrow it as you go down?
I would like to point out that several streams have gone through this process as is and have come out not impaired. So they are busting the screening criteria at the 75th percentile, but as they go through it, they're not impaired. So at this point, this is extremely costly to do steps 2 and steps 3. Extremely costly. They don't have a lot of resources at this point. So limiting it to this part, seeing that we do have both impaired and unimpaired streams coming out of this, I think we're doing pretty good coming up with a way to assess a narrative standard at this point.
And Mary passed this out. These are the golly, I guess it's the end of the day, y'all. So it's 2016 screening values. This is the 75th percentile ecoregion screening values. So, for example, the Boston's is 0.036. That's the 75th percentile. So the 25th, we can put what that might be a good exercise then to show what these values really are. That's low, at 0.036. However, people have chosen, other states have chosen standards just like that, I will say. Yes, Ryan.
So, Colleen, my answer to your question is why not change that number is because if you change that number, you're going to throw a ton of streams into Category 3 for no other reason than throwing it into Category 3, right? I mean, if you make through the screening level and you get into insufficient data, it goes into Category 3?
Yeah, yes, I'm sorry.
So instead of keeping them in Category 1, you're just going to throw them in Category 3 because you're going to get past that first screening level. You're not going to have the data to do the additional assessment, and so they're just going to sit in Category 3. I mean, that's why I would say, as opposed to only throwing into Category 3 those streams that are the worst, that you're going to prioritize your data collection process to. I mean, hopefully DQ uses Category 3 to go, hey, I need more data here. And so if you throw in those worst of the worst streams into Category 3, then they prioritize them for data. If you throw everything into Category 3, because what Sarah was saying, I'm starting to pick up on, if 0.036 is the 75th percentile, what's the 25th percentile in the Bostons?
0.1.
Detection limit? I mean, so we'd be throwing, Tate, we'd be throwing streams into Category 3 because they're at the detection limit maybe. And that doesn't seem, I don't think that's something I would want you to do.
And I guess, really, Colleen, Mike, I don't want you to think that we're disregarding. It's not that this is being disregarded. This is a very good point, and I really see it as just everybody finally getting a chance to dig into how these assessments are done, how we look at the data in stepwise fashion, how we carry these things out, especially for nutrients, because this is quite different than any other of the other parameters throughout the whole Reg 2. This is unique in how we do this, just because it's the narrative. But I do think what we need to do is to show what we're looking at as far as maybe the 25th and the 50th. What does that look like? Then go back and look at Are we looking at a shifting condition? Are we comparing to a shifting condition? Do we need to go back 10 years? Is it appropriate to go back 10 years? Is it really even shifting at all, these 5-year periods of record that we're looking at? If we were to go back, and we have the ability, there's plenty of data, we could go back and do it. But these are some of the issues, like when we're sitting around in front of it and monitor, just these are, in making these decisions, we do have to think about resources. We do have to think about, are we allocating our resources in the best way and really getting the ones that fall to the top, the streams and the segments that that rise to the top, not fall to the top. And those, again, are going to be those 0.036s and 0.04s, looking at the more mountainous ecoregions. And the Ozark Highlands, which is 0.1, which is higher than Arkansas River Valley, actually, which is interesting. But we'll have that. We'll go back and look at that. Is there anything else that that anybody else would like to see us dig into as it relates to this kind of first step, I guess, really, of the nutrient assessment methodology? Yes.
What Ryan and Tate have said, that makes sense, and I guess my bias is that this is a protocol for assessing whether the streams are meeting the designated aquatic life uses. But because we don't have numeric in-stream standards for any other purposes except for the ones on Beaver Lake, I'm kind of looking at that first step of, I'd like to see sort of where these streams are in terms of other uses, because the nutrients are going to be affecting other uses as well, even though this assessment is not for those other uses. So that's kind of my bias on it.
So are you saying you want to see so we have certain stations that may exceed this,
and I guess, the answer is people can go out and crunch the numbers themselves if they're interested, just to see what the nitrogen and phosphorus levels are in stream. But right now, I guess I would have, as Ryan said, it would be on a Category 3 for warranting further study. Mm-hmm. And that further study, people could look at that and say, I don't really care about the biota, but I care about some other things that are impacted by nutrients, and so I want to look at those streams further. But, I understand that there's a stigma attached to even being put in Category 3.
Well, I can see how that information would be, it seems like that information would be something that we could put in the 305B report, perhaps, or, right, yeah. Yes, Sean. Yeah, we can put so Sean was just asking the number of samples that were utilized, that were compiled to come up with these screening values. And we can put all that, we already have all that, we can put all that in the information to you guys. So as soon as we get it, then we can get it on the website for you.
I'm sorry, I have one other request. So when you're putting the 2014 in here, could you also put the pristine historical numbers in there as well, so we could kind of get an idea of how these have changed or not changed or anything like that? That would be, if it's not too much work, that would be great.
Well, as far as defining least disturbed or pristine, what we could do is just we'll put the 25th percentile of all available data for each ecoregion, and that would be near historic conditions or least disturbed conditions in theory. But for the Ozark Highlands, I'm pretty sure it's 0.02, just so frame of reference.
So we're caught between, I'm feeling we're caught between two spots here. We're caught between getting through, I don't know if anybody has any questions. So if you look on the nutrient assessment methodology on page 48, my page 48, there's more to the decision tree here. I don't know if anybody else had anything to comment on. We are bumping up against 15 minutes until closing, I'm sorry, I didn't want to say that, till the end of the allocated time that we have for today and this stakeholder session. And so we're not closing. We don't close until 4:30. Other people can stay longer, actually, 5:30. But anyway, so I guess I'm throwing out to the group, what would you like to do? Would you like to recap, look back at outstanding topics, future discussions? Do you want to keep digging through the decision tree, the flow chart here for nutrient assessments? There's always it's always good to wrap up and see where you've come and where you're going. But is everybody good with like doing a recap and wrap up? I don't know. Do you want to? What do you want to do?
My suggestion, the nutrient one is is an important enough one and a complicated enough that we probably ought to park it
Okay.
for
Good.
next meeting so that we can deal with it in its entirety rather than kind of divide it up in the next 15 minutes.
All right.
And if there's something we can handle in 15 minutes, do so, but it sounds like we're probably at a wrap-up
Let's do that.
place.
Okay. Well, so what we've heard, what I feel like we've heard, I may want to ask Mary or Jesse to chime in, but at least with this discussion, go back and look at the different percentiles for the ecoregion screening values that we're looking at for the nutrient assessment. Go back maybe 10 years and see has it shifted? Have these values shifted? Go back and look at the other percentiles. And again, if anybody comes up in this over the holiday period, you're sitting there eating turkey, and all of a sudden a recommendation for the appropriate percentile come to you, go ahead and make notes on your phone so we can have that. And what else? Then I'm trying to remember what else that we came up with. Mary, do you have any other? Ma'am, can you talk in the microphone, please? There's one. Push the button.
So we're going to go back and look and see how other states are handling both discrete and continuous data. That was the other thing that we're going to look up.
Right.
Right, that's all.
Does anybody have any, did we miss anything? Any other small bits? Yes, Alice.
What was the document, the other states? You referred to some document that we could look at.
Go ahead, Tate. Association of Clean Water Administrators. Yeah, but we're gonna try to get that out on the website, Alice.
Thank you.
Did everybody get? We'd made commitments last time to get certain publications on our website. Did we get all of those that everyone wanted to see? No, we didn't. We didn't get all the ones that everybody wanted. We're still working on those. Okay. Okay, Teresa's got something.
I just wanted to clarify on the recommendation of looking at what other states have gone back and done with discrete and continuous. I really want to see how they've been able to handle when they've had two data sets like Ryan described over 5 years. So how have they been able to, weigh those appropriately? Just to clarify what my question was.
Okay, if that's out there, well, okay, thank you. Well, I think we have 10 minutes left, but I think we'll go ahead and adjourn for the day. Just quickly before you grab all of your stuff and everything, I really do want to say thank you for sticking around for 3 hours and sitting through this and thinking about this, giving thoughtful comments and criticism. I think we're doing a good job of critically thinking through all of these. We have a lot of good minds here, intelligent folks, and so we're, you may not think it, but you guys are smarter than you think. And then I also want to say thanks to USGS for coming in, and please, we will send out an agenda, and we'll send out those topics that we're going to be addressing for the 12th. If there's any change in that, we'll let you know. And thanks, everybody, for being on the phone with us. And Merry Christmas, everybody. We'll see you on the 12th, and if not, then we'll let you know. Thanks.